Hey, what's up everybody? This video we will be discussing indexes. The best way to think about it is just to take a book, look in the back. There's often an index here, which basically has a huge list of topics, and it says what page they're on. So you'd be like, oh wow, that looks fun, queries. Go to page 2078. Wow, it's right there. I found that so fast, I didn't have to go search through the entire book to find it. That's an example of an index. It's basically a list of where certain data points are. Another kind of index is you can think of a phone book. You go to a phone book and you search through the phone book, you find someone's name, we go to grandma, and it'll have their phone number right there. That's another type of index. It's where the data is sorted in a way that you can easily find it and the data is right there, versus an index in the back where it's a list of data pointing to where it's at. The one we first discussed is known as a non-clustered index. What that means is that the data is not actually where the index is. The index is a separate thing, and it basically just sorts the data, and it's basically a point that tells you how to get to the data. So the way it works in a book is you find the topic, and it'll tell you where to go. 365, for example. Go to page 365. That's a non-clustered index. A clustered index is like the phone book, where it actually reorganizes the actual data in a way that's easy to use. Non-clustered points to the data. Clustered organizes the actual data. So we can have multiple non-clustered indexes. That's because a non-clustered index is basically just a list of references that point you to the data, so we could organize it in different ways. But as for the clustered index, we can only have one of those. That's because it actually organizes the data that way. So think of a phone book, it's organized A to Z, or however. You go through there and you find it. That's a clustered index, it organizes the data. Well, what if I wanted to put the data in by the phone number? So the smallest phone number, like 0000001, which would be an awful way to organize a phone book at the beginning, and then 999999999 at the end. That's an awful way to design a phone book, like I just said, but that is another example of a clustered index. That's because it actually reorganizes the data. That's why you can only have one of those, because a phone book can't be listed A to Z and also by the size of the phone number. See what I mean? It's conflicting. You can't have both at the same time. You can only have, okay, this is sorted by name. Or, oh, this is sorted by phone number. You can't have both. Now you could make the phone number size or whatever as a non-clustered index, where it would be like this. It'd have the actual phone numbers in the back, and it would point to where it's located. So at the beginning of the index, it would be like, okay, the phone number that's 000000001 would be on page 743. The phone number with 00000000002 is on page 242. You see that the actual data isn't organized by the phone numbers, but you can use that non-clustered index that sorts it that way and has a reference to the actual data where it's located. Now you guys are probably sick and tired of me rambling about this, so let me just explain how this makes sense in databases. Well, when we're working with a database, often we will use a certain column for certain things. And that column will be used frequently, and we want that to be like super fast. So we want the database to know how to use it the best way. So we create an index. The database understands the index, so that way when you tell it to do something, it can do it faster, rather than it having to go through all of the data, which is called a table scan. When you're working with a database with millions of rows, that can take forever. If you have an index, it'll use an index seek, which will basically know where to start searching for that data. That's awesome, because it makes our queries tons faster and saves a lot of resources. There's downsides to it though, because when you create an index, not only does the actual table have to update whenever you update it, but you also have to update the indexes. Think of like a book. When you add something to this book or you change something within this book, not only does the actual book content in the beginning of the book change, but also when you flip to the back, the index must also be updated. Otherwise, all this index information is going to be out of date and useless. So that's a downside to indexes, is when you update your information, it might take a little longer. In a database query, we might say something like select the first name, last name, and the phone number and the email of the user with the user ID of 72, for example. Well, I kind of said that in English, but when you're actually working with a database, it might be more like select first name, last name, email, phone number, where user ID equals 72. That would be an example of a database query. Now that where clause is using the primary key. So basically, the database is going to go through the table, find the person with the user ID of 72, and then display their first name, last name, phone number, and email. Well, that where is using a column that has an index. The primary key is usually the one that's going to have the clustered index, so that's the way it actually sorts the data. So now, it doesn't have to go through the entire table to find the person with the ID of 72. Because imagine if it was just random data thrown in there with no organization. You have 2 billion rows, right? And the database has to go through and find the one individual row with the user ID of 72. Go to the first one, nope, not 72. Second one, nope, not 72. Third one, nope, not 72. And keep going on and on until it finally found the person with the user ID of 72. Basically, that would take forever. But with a clustered index, it knows, well, 72 is going to be in this part of the database. It comes after 60 and comes before 80, because that's the way it's sorted. So it's going to be like, boom, got it, done. That is how indexes kind of work. So clustered indexes are going to be faster and better, but you can only have one. That's usually the primary key, but it doesn't always have to be, depending on the database and what your goal for the database is. The non-clustered indexes, which are like the index in the back of a book, those are still good and they are recommended if you're doing something where you're like, where first name equals John. Now, it has a list of all the Johns and where they're located on the database, or on the table, I guess. That's also a good thing. But you don't want to have an index on something you're not going to be using a lot, because you'll just have to have another thing updated. Another thing, you don't often want to do where clauses, which is like where first name is Caleb, without that column that you're searching being a indexed column, because it can take forever. Another reason for indexes is to increase the speed of joins. So the way the join works is it takes data from one table and then another table and combines it together by the primary key and foreign key connection. So think of a users and comments. So a user posts a comment. So you have a user table and you would have a comment table. And let's just draw rows on here. So we have this guy. I'm just going to draw pictures just because it's funner. So we have 3 people over here. And we have 4 comments on a website or review, or it doesn't really matter. Well, this one comment is posted by one person, and one person can post multiple comments. It's a one-to-many relationship. Well, when we want to output this to where we can review the data, we want to use a join so it's not across multiple tables. Because if you're thinking like, this comment was posted by the user with the user ID of 72, you're not going to know who that is right off the top of your head, because that's a foreign key connection. So rather, you want to replace that 72 with the actual name of that person, or the username. That's a join, and it's all done after the database is created. It's all for the query side. So basically, this is what is defined in our database, and we want to output with a join a new table that looks more pretty and easier to read. When we do this, we're going to do something that says the user ID of this the user ID of this table is the same as the user ID in this table. So if a comment has the user ID of 72, we know that it's done by the user with the user ID of 72. That's a foreign key connection, which we've talked about like this entire series, so I'm not even going to explain that anymore. But now down here, in this table, it's going to say Caleb Curry. Then it'll put the comment, and it'll join that. Well, this is also done with a where clause in some cases. For different databases, the terms might be a little different, but basically, that column that you're connecting by, which in this case would be the primary key, needs to be indexed to make it faster. So whenever you're joining a certain column, the two tables, the column you're joining should be indexed. You can also have something that's known as a composite index, which is an index that is an index on two or more columns. So think of like a first name and a last name, or last name, first name. Now the thing about these is, when you use the indexes, so let's say you select where first name equals this and last name equals that, you have to do them both or it's not going to use that index. Now there are exceptions to this. Think for MySQL actually, if you order them in a certain way, like this, if you put an index on the last name and then also the first name, you can do a where clause for both the last name and first name, so finding everybody with the last name Curry and the first name Caleb would be really fast. But the way this is set up, you can also do the leftmost one too. So you could say, find the person with the last name Curry. That's going to work. But in this case, you couldn't do it with the first name because it's not on the left. So that's just the way MySQL has it set up. So different database systems might have it set up differently, where you can't search with them individually, or you can. But most likely, when you make a composite index, you should expect to always use that index by itself. Unless you have it set up to where you make a pretty awesome index that can be optimized to do multiple different queries that you need to do. Like if I'm going to make a ton of queries where I put the last name as the where, and then I'm going to make a ton of queries where I put last name and first name for the where, this would be a good way to set that up because I'm making one index for last name, first name, that can also be used for just last name. So yeah, that's just the basic introduction to indexes. Yeah. I'm not going to be giving you tons of syntax to actually making them because, like you should know by now, this is a database design course. We're just trying to learn how to design our indexes on our tables so that our database works good. So that's something you may have to learn more once you actually program a database, because you can test the speed of the actual indexes to see this for speed optimization to make the database as fast as possible. You can't really do that if you're only designing a database. You can only get so far when designing indexes with the database, but you can get pretty far because, I mean, obviously you'll likely be using the primary key for where clauses and joins, so that's something that's good to have a clustered index on. So yeah, that's about all guys. Thank you for watching and be sure to subscribe. I'll catch you in the next video.